Welcome to Passco Africa. Here is the question. A body starts from rest and travels a distance of 100 m, 200 m and 300 m in successive equal time intervals of tens. Which of the following statements is/are true about the body? I. It has uniform acceleration 2. It has constant velocity 3. It has non-uniform velocity. Now, try it yourself. Step 1. Understanding the problem. A body starts from rest and travels a distance of 100 m, 200 m, and 300 m in a certain time. What is the time taken to travel these distances? To solve this problem, we need to use the concept of uniformly accelerated motion and the equation of motion. The equation of motion states that an object under constant acceleration changes its velocity by a certain amount in a given time. Step 2. Writing the equation of motion. The equation of motion is given by S equals ut plus at caret 2, where S is the distance traveled, U is the initial velocity, t is the time taken, and a is the acceleration. Since the body starts from rest, the initial velocity is 0. Step 3. Rearranging the equation. Rearranging the equation to solve for time, we get t squared equals 2/a. Step 4. Understanding the formula. The formula t squared equals 2/a shows that the time taken to travel a certain distance is directly proportional to the square root of the distance and inversely proportional to the square root of the acceleration. Step 5. Applying the formula to the problem. We are given three distances, 100 m, 200 m, and 300 m. We need to find the time taken to travel these distances. Let's assume the acceleration is constant. We can use the formula to find the time taken for each distance, t squared equals 2/at equals sqrt. Step 6. Calculating the time for each distance. For 100 m, t equals sqrt. For 200 m, t equals sqrt. For 300 m, t equals sqrt. Step 7. Simplifying the calculations. Since the acceleration is constant, we can simplify the calculations by finding a common denominator for each distance. For 100 m, t equals sqrt. For 200 m, t equals sqrt. For 300 m, t equals sqrt. Step 8. Finding the time for each distance. Now that we have simplified the calculations, we can find the time taken for each distance by plugging in the values for each distance. For 100 m, T equals SQRT equals SQRT for 200 m, T equals SQRT equals 2 multiplied by SQRT for 300 m, T equals SQRT equals SQRT. Step 9. Finding the time ratio. To find the time ratio, we can divide the time taken for each distance by the time taken for 100 m. For 200 m, ratio equals / equals 2 for 300 m, ratio equals / equals SQRT. To recap, we solved the question by 1. Understanding the problem, 2. Writing the equation of motion, 3. Rearranging the equation, 4. Understanding the formula, 5. Applying the formula to the problem, 6. Calculating the time for each distance, 7. Simplifying the calculations, 8. Finding the time for each distance, 9. Finding the time ratio. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. A centripetal force is one that acts in the direction of motion. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. A man 1.8 m tall stands in front of a plane mirror. Calculate the shortest length of mirror that will enable him to see his total length. Now, try it yourself. Step 1. Understand the mirror equation. The mirror equation is given by 1/f equals 1/do plus 1/d, where f is the focal length of the mirror, do is the object distance, and d is the image distance. Step 2. Identify the object distance. In this problem, the man is standing in front of the mirror, and we want to find the shortest length of the mirror needed. This means we want to find the minimum object distance for which the mirror will produce a virtual image of the man. Step 3. Identify the image distance. Since the mirror is producing a virtual image, the image distance is negative. Step 4. Use the mirror equation to find the focal length. We can now substitute the values of do and d into the mirror equation to find the focal length. Math 1/f equals 1/do plus 1/d. However, we don't know the value of do or d. To solve this problem, we need to use the fact that the angle of view is the same for both the object and the image. Step 5. Use the angle of view to find the minimum object distance. The angle of view is given by tan equals h/do, where theta is the angle of view, h is the height of the man, and do is the object distance. Step 6. Find the angle of view. Since the angle of view is the same for both the object and the image, we can use the fact that the tangent of the angle of view is equal to the ratio of the height of the man to the object distance. Math tan equals h/do. Step 7. Find the minimum object distance. To find the minimum object distance, we can use the fact that the tangent of the angle of view is equal to the ratio of the height of the man to the object distance. Math tan equals h/do, do equals h/tan, math do equals 1.8 m/tan. Step 8. Find the focal length. Now that we have the minimum object distance, we can use the mirror equation to find the focal length. Math 1/f equals 1/do plus 1/d. Substituting the values of do and d, we get math 1/f equals 1/1/. Simplifying the equation, we get math 1/f equals 2/f equals 0.9 m/tan. Math f is almost equal to 0.9 m/0.333. F is almost equal to 2.7 m. The shortest length of the mirror needed is approximately 2.7 m. To recap, we solved the question by 1. Understand the mirror equation. 2. Identify the object distance. 3. Identify the image distance. 4. Use the mirror equation to find the focal length. 5. Use the angle of view to find the minimum object distance. 6. Found the angle of view. 7. Found the minimum object distance. 8. Found the focal length. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. A negatively charged rod is brought near the cap of gold-leaf electroscope. The rod is then removed. Which of the following statement is correct? Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. A radio circuit employing 1 microfarad capacitor operates at an alternating current supply of 50 Hz. Calculate the reactance of the circuit. 3.0 x 10⁴. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. A resonance tube of length 1 sounding the first overtone satisfies the equation L plus C equals V/ for F. The end correction C may be determined by. Now, try it yourself. Step 1. Understanding the equation. The given equation is L plus C equals V slash for F. To find the end correction C, we need to understand the components of this equation. Here, L is the length of the tube, V is the velocity of sound in the gas, F is the frequency of the first overtone, and C is the end correction. Step 2. Velocity of sound. The velocity of sound in a gas is given by V equals square root, where p is the bulk modulus of the gas and ρ is the density of the gas. However, for the purpose of this calculation, we'll assume a constant velocity of sound, as the exact values of b and ρ are not provided. Step 3. Frequency of the first overtone. The frequency of the first overtone is given by F equals V slash L, where V is the velocity of sound and L is the length of the tube. However, in this case, we're given the frequency F as a constant, and we need to find the end correction C. Step 4. Rearranging the equation. To find the end correction C, we need to rearrange the given equation L plus C equals V slash for F. We can start by multiplying both sides by 4F to get 4FL plus 4FC equals V. Step 5. Finding the end correction. Now, we can substitute the expression for the frequency of the first overtone V slash L into the equation for FL plus 4FC equals V. This gives us 4LV slash L plus 4FC equals V, which simplifies to 3V plus 4FC equals V. Step 6. Isolating the end correction. To isolate the end correction C, we need to rearrange the equation 3V plus 4FC equals V. Subtracting 3V from both sides gives us 4FC equals V, 3V. Dividing both sides by 4F gives us C equals slash 4F. Step 7. Simplifying the expression. However, upon closer inspection, we realize that the expression for the end correction C can be simplified further. The velocity V is independent of the frequency F, so we can substitute the expression for the frequency of the first overtone V slash L into the equation C equals slash 4F. This gives us C equals slash V slash L. Step 8. Simplifying further. Multiplying both the numerator and the denominator by 4L slash 3V, we get C equals 4L slash. Step 9. Simplifying even further. Simplifying the expression C equals 4L slash gives us C equals 4L slash. Step 10. Final expression for end correction. However, we must note that the final expression for the end correction C can be simplified further by combining the constants. The final expression for the end correction is C equals. Step 11. Simplifying the final expression. However, since V equals square root equals V, the expression equals V, 3V equals dash 2V. Step 12. Final expression for end correction. Substituting equals dash 2V into the expression C equals, we get C equals. Step 13. Final expression for end correction. Simplifying the expression C equals gives us C equals dash 8L slash 9V. Step 14. Simplifying the final expression for end correction. However, we can simplify this expression further by taking the absolute value of the end correction in C. The final expression for the end correction is C equals dash 8L slash 9V equals 8L slash 9V. To recap, we solved the question by 1. Understanding the equation, 2. Velocity of sound, 3. Frequency of the first overtone, 4. Rearranging the equation, 5. Finding the end correction, 6. Isolating the end correction, 7. Simplifying the expression, 8. Simplifying further, 9. Simplifying even further, 10. Final expression for end correction, 11. Simplifying the final expression, 12. Final expression for end correction, 13. Final expression for end correction, 14. Simplifying the final expression for end correction. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. An annular eclipse occurs when the Earth comes between the Moon and the... Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. An ideal gas at 27 degrees Celsius and pressure of 1.0 x 10⁵ Newton meters minus 2 is compressed at constant temperature until its volume is halved. Calculate the final pressure of the gas. 2.5 x 10⁵ Newton meters. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. An unstable radioactive nucleus decays according to the equation AZP-A 4Z2D plus H42E. Which of the following statements is not true about the decay? Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. In the diagram below, a source of potential difference, V, supplies a current, I, to the two resistors, Re and R2. Calculate the ratio of current through R1 to current through R2. R1/R. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Magnetic saturation occurs if the magnet is demagnetized. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. One major difference between an alternating current and a direct current is that an alternating current gives a constant value but direct current gives root mean dash. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Sensible heat and latent heat differ in their sensitivity to internal energy changes. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. The following are thermometric properties except potential difference across platinum. Now, try it yourself. Step 1. Definition of thermometric properties. Thermometric properties are the characteristics of a thermometer that allow it to measure temperature accurately. They include sensitivity, accuracy, precision, range, linearity, hysteresis, and thermal shock resistance. Step 2. Sensitivity. Sensitivity is the ability of a thermometer to respond to changes in temperature. It's measured in terms of the change in temperature per unit change in the thermometer's scale reading. A thermometer with high sensitivity will have a narrow scale division, indicating a higher degree of precision. Step 3. Accuracy. Accuracy is the closeness of a thermometer's reading to the true temperature. It's measured by comparing the thermometer's reading with a standard temperature. A thermometer with high accuracy will have a small deviation from the true temperature. Step 4. Precision. Precision is the consistency of a thermometer's readings. It's measured by repeating the measurement multiple times and calculating the standard deviation of the readings. A thermometer with high precision will have a small standard deviation. Step 5. Range. Range is the temperature range over which a thermometer can measure accurately. It's measured by determining the lowest and highest temperatures at which the thermometer can operate. Step 6. Linearity. Linearity is the straightness of a thermometer's scale. It's measured by plotting the thermometer's reading against the true temperature and checking if the plot is a straight line. Step 7. Hysteresis. Hysteresis is the lag in a thermometer's response to changes in temperature. It's measured by comparing the thermometer's reading with the true temperature after a change in temperature. Step 8. Thermal shock resistance. Thermal shock resistance is the ability of a thermometer to withstand sudden changes in temperature. It's measured by exposing the thermometer to a rapid change in temperature and checking if the thermometer's reading is affected. To recap, we solved the question by 1. Definition of thermometric properties, 2. Sensitivity, 3. Accuracy, 4. Precision, 5. Range, 6. Linearity, 7. Hysteresis, 8. Thermal shock resistance. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. The half-life of a radioactive gas was investigated on a gigamolar counter. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. The maximum reading on the ammeter may be extended by shunting the. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. The pressure at a point in a liquid always acts vertically downwards. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. The temperature of a brass rod 60 cm increases by 70 oC. Calculate the new length of the rod. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. The tendency of a body to remain at rest or to continue its state of uniform. Now, try it yourself. Step 1. Understanding Newton's first law of motion. Newton's first law of motion, also known as the law of inertia, states that an object at rest will remain at rest, and an object in motion will continue to move with a constant velocity, unless acted upon by an external force. Step 2. Defining inertia. Inertia is the tendency of a body to resist changes in its motion. It is a measure of an object's mass and its resistance to acceleration. Step 3. Factors affecting inertia. There are three main factors that affect inertia: mass, shape, and size. The greater the mass of an object, the greater its inertia. Step 4. Types of inertia. There are two types of inertia: translational and rotational. Translational inertia is the tendency of an object to resist changes in its linear motion, while rotational inertia is the tendency of an object to resist changes in its rotational motion. Step 5. Examples of inertia. Examples of inertia include a car continuing to move in a straight line, a bowling ball continuing to roll on the ground, and a spinning top maintaining its rotational motion. Step 6. Measuring inertia. Inertia is measured in units of mass, which is typically measured in kilograms. The greater the mass of an object, the greater its inertia. Step 7. Applying inertia in real-life scenarios. Inertia has numerous applications in real-life scenarios, including engineering, mechanics, and even sports. Understanding inertia will help you solve problems related to motion, forces, and energy. To recap, we solved the question by 1. Understanding Newton's first law of motion, 2. Defining inertia, 3. Factors affecting inertia, 4. Types of inertia, 5. Examples of inertia, 6. Measuring inertia, 7. Applying inertia in real-life scenarios. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which feature of the eye performs the same function as the diaphragm in the lens camera? Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which instrument is more suitable for measuring the internal resistance of an accumulator? Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which instrument operates on the principle of magnetic effect of electric current? Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following demonstrates a simple harmonic motion? I. Blowing the column of air in a closed pipe. 2. A satellite revolving round the Earth. 3. A mass on a spring in a vertical motion. Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following electrical devices uses energy stored in a capacitor? Now, try it yourself. Step 1. Understanding capacitors. A capacitor is an electrical device that stores energy in an electric field. It consists of two conductive plates separated by a dielectric material, which can be a vacuum, air, or a solid material like ceramic or plastic. Step 2. Electric field and potential difference. When a potential difference is applied across the plates, an electric field is created. The electric field causes the positive charges on one plate to be attracted to the negative charges on the other plate. Step 3. Capacitance. The capacitance of a capacitor is a measure of its ability to store energy. It's defined as the ratio of the charge on one plate to the potential difference across the capacitor, C equals Q/V. Step 4. Energy stored in a capacitor. The energy stored in a capacitor is calculated using the formula E equals 1/2 CV superscript 2, where E is the energy stored, C is the capacitance, and V is the potential difference across the capacitor. Step 5. Derivation of energy stored in a capacitor. To derive the energy stored in a capacitor, we can use the formula for capacitance and substitute it into the energy equation, E equals 1/2 times V superscript 2. Simplifying the equation, we get E equals 1/2 QV. Now, using the formula for capacitance, we can substitute it into the energy equation, E equals 1/2 times V. Simplifying further, we get E equals 1/2 CV superscript 2. Step 6. Understanding the formula. The formula equals 1/2 CV superscript 2 shows that the energy stored in a capacitor is directly proportional to the capacitance and the square of the potential difference across the capacitor. This means that if the capacitance and potential difference increase, the energy stored in the capacitor will also increase. Step 7. Conclusion. In conclusion, the energy stored in a capacitor is an essential concept in the field of electricity and electronics. By understanding how energy is stored in a capacitor, you'll be able to solve problems related to capacitors and circuits. Remember, the formula equals 1/2 CV superscript 2 is a key concept to master for WASSCE Physics. To recap, we solved the question by 1. Understanding capacitors, 2. Electric field and potential difference, 3. Capacitance, 4. Energy stored in a capacitor, 5. Derivation of energy stored in a capacitor, 6. Understanding the formula, 7. Conclusion. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following equation represents the distance traveled by a body falling freely under gravity? The symbol S, G, and T have their usual meaning. S equals GT2. Now, try it yourself. Step 1. Identify the variables. We need to identify the variables involved in the problem, including the initial velocity, the acceleration due to gravity, and the time for which the body falls. Step 2. Choose the correct equation. We need to choose the correct equation of motion to use. In this case, we'll use the equation S equals ut plus gt caret 2, where s is the distance traveled, u is the initial velocity, t is the time, and g is the acceleration due to gravity. Step 3. Understand the formula. Let's break down the formula into its components. The first term, ut, represents the distance traveled due to the initial velocity. The second term, gt caret 2, represents the distance traveled due to the acceleration due to gravity. Step 4. Apply the formula. We can now apply the formula to the given problem. Let's assume the initial velocity is 0, the acceleration due to gravity is 9.8 m/s caret 2, and the time is 5 seconds. S equals 0 plus caret 2, s equals 122.5 m. Step 5. Consider edge cases. We need to consider edge cases, such as what happens when the initial velocity is not 0 or when the acceleration due to gravity is not 9.8 m/s caret 2. Step 6. Practice with examples. Let's practice with some examples to reinforce our understanding of the concept. Step 7. Review the concept. Finally, let's review the concepts we've covered, including the equations of motion and the concept of uniformly accelerated motion. To recap, we solved the question by 1. Identify the variables, 2. Choose the correct equation, 3. Understand the formula, 4. Apply the formula, 5. Consider edge cases, 6. Practice with examples, 7. Review the concept. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following features describe a pyrometer? Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following indicates a change of state of matter? Now, try it yourself. Step 1. Understanding the basics. To understand the change of state of matter, we need to know the basic states of matter: solid, liquid, and gas. These states are characterized by the arrangement of particles and their movement. Solids: particles are closely packed and have a fixed position in space. Liquids: particles are close but can move past each other. Gases: particles are widely spaced and move freely. Step 2. Factors influencing the change of state. The change of state of matter is influenced by two primary factors: temperature and pressure. Temperature: an increase in temperature provides energy to the particles, causing them to move more rapidly and spread out. Pressure: an increase in pressure compresses the particles, causing them to move closer together. Step 3. Types of change of state. There are three types of change of state. 1. Melting: a solid changes to a liquid. 2. Vaporization: a liquid changes to a gas. 3. Condensation: a gas changes to a liquid. 4. Sublimation: a solid changes directly to a gas. 5. Deposition: a gas changes directly to a solid. Step 4. Understanding the change of state diagram. A change of state diagram, also known as a phase diagram, is a graphical representation of the relationship between temperature, pressure, and the state of a substance. Mermaid graph: LA, temperature increases; BB, temperature increases; CA, pressure increases; DC, pressure increases; B. Step 5. Cooling as a change of state. Now, let's explore how cooling affects the change of state of matter. Cooling reduces the energy of the particles, causing them to move more slowly and come closer together. Cooling can cause a substance to change from a gas to a liquid or from a liquid to a solid. Step 6. Real-life applications. The change of state of matter has numerous real-life applications, including refrigeration, cooling a substance to change its state from liquid to gas. Freezing, cooling a substance to change its state from liquid to solid. Distillation, heating a substance to change its state from liquid to gas. Step 7. Conclusion. In conclusion, the change of state of matter is a fundamental concept in physics that requires a thorough understanding of the underlying principles. By grasping the factors that influence the change of state, types of change of state, and real-life applications, you'll be better equipped to answer questions on this topic in the WASSCE/WAEC exams. To recap, we solved the question by 1. Understanding the basics; 2. Factors influencing the change of state; 3. Types of change of state; 4. Understanding the change of state diagram; 5. Cooling as a change of state; 6. Real-life applications; 7. Conclusion. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following is correct about ray from air entering triangular glass prism? Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following is not a natural source of energy? Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following is the correct relationship between the velocity, v, and the frequency of a wave? Now, try it yourself. To recap, we solved the question by. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following are correct about a p-semiconductor crystal I? It has holes as majority charge carriers 2. It has electrons as minority charge carriers 3. It has equal number of holes and electrons. Now, try it yourself. Step 1. Formation of p-semiconductor crystal. A p-semiconductor crystal is formed when a small amount of a group 3 element, such as boron, is added to a silicon crystal. This process is known as doping. The group 3 element has one less electron in its outermost shell, resulting in an excess of holes in the silicon crystal. Step 2. Understanding the energy band structure. To comprehend the behavior of a p-semiconductor crystal, we must first understand its energy band structure. The energy band structure consists of the valence band and the conduction band. The valence band is the energy range where electrons are bound to the atom, while the conduction band is the energy range where electrons are free to move. Step 3. Fermi level. The Fermi level is the energy level at which the probability of finding an electron is 50%. In a p-semiconductor crystal, the Fermi level lies in the valence band, indicating an excess of holes. Step 4. Conductivity of p-semiconductor crystal. The conductivity of a p-semiconductor crystal is due to the movement of holes. When a p-semiconductor crystal is connected to a power source, the holes move towards the positive terminal, allowing the crystal to conduct electricity. Step 5. Application of p-semiconductor crystal. P-semiconductor crystals are used in a variety of applications, including transistors, diodes, and solar cells. They are also used in the production of integrated circuits. Step 6. Comparison with n-semiconductor crystal. N-semiconductor crystals, on the other hand, have an excess of electrons. While both p and n-semiconductor crystals are used in electronic devices, they have different properties and applications. Step 7. Conclusion. In conclusion, a p-semiconductor crystal is a type of semiconductor material with an excess of holes. Its energy band structure, conductivity, and application make it an essential topic in physics. Understanding the properties of a p-semiconductor crystal is crucial for students to excel in their WASSCE exams. To recap, we solved the question by 1. Formation of p-semiconductor crystal, 2. Understanding the energy band structure, 3. Fermi level, 4. conductivity of p-semiconductor crystal. 5. Application of p-semiconductor crystal. 6. Comparison with n-semiconductor crystal. 7. Conclusion. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following are the main practical application of bits I tuning stringed instruments to? Determining an unknown frequency. 3. Determining velocity of an object. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following sequences describe the operation of internal combustion engine? Now, try it yourself. Step 1. Intake stroke. Narrator. The engine's intake stroke begins when the piston moves downwards, creating a vacuum in the cylinder. This draws in a mixture of air and fuel, which is then compressed by the piston. Step 2. Compression stroke. Narrator. The compressed air-fuel mixture is then ignited by a spark plug, causing a small explosion that pushes the piston downwards. Step 3. Power stroke. Narrator. The piston's downward motion is what ultimately powers the engine, converting the chemical energy stored in the fuel into mechanical energy. Step 4. Exhaust stroke. Narrator. As the piston moves upwards, it pushes the exhaust gases out of the cylinder, preparing it for the next intake stroke. Step 5. Spark timing. Narrator. The spark plug's timing is crucial, as it must ignite the air-fuel mixture at the precise moment to maximize power output and efficiency. Step 6. Fuel injection. Narrator. Modern engines often employ fuel injection systems, which spray fuel into the cylinder at the precise moment to optimize combustion efficiency. Step 7. Cooling system. Narrator. The engine's cooling system plays a vital role in maintaining optimal operating temperatures, ensuring the engine runs efficiently and lasts longer. To recap, we solved the question by 1. Intake stroke, 2. Compression stroke, 3. Power stroke, 4. Exhaust stroke, 5. Spark timing, 6. Fuel injection, 7. Cooling system. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following sources of energy are classified as renewable? I. Sun. 2. Wind. 3. Charcoal. 4. Petroleum. Now, try it yourself. Step 1. Solar energy. Narrator. Solar energy is the energy generated from the sun's rays. This energy is harnessed using solar panels, which convert sunlight into electricity. Solar energy is a clean and renewable source of energy, producing no greenhouse gas emissions or pollution. Step 2. Wind energy. Narrator. Wind energy is the energy generated from the wind. Wind turbines convert the kinetic energy of the wind into electricity. Wind energy is another clean and renewable source of energy, producing no greenhouse gas emissions or pollution. Step 3. Hydro energy. Narrator: hydro energy is the energy generated from the movement of water. Hydroelectric power plants harness the energy of flowing water to generate electricity. Hydro energy is a reliable and renewable source of energy, producing no greenhouse gas emissions or pollution. Step 4. Geothermal energy. Narrator: geothermal energy is the energy generated from the heat of the earth. Geothermal power plants harness the heat from underground reservoirs to generate electricity. Geothermal energy is a clean and renewable source of energy, producing no greenhouse gas emissions or pollution. Step 5. Biomass energy. Narrator: biomass energy is the energy generated from organic matter such as wood, crops, and waste. Biomass power plants burn biomass to generate electricity. Biomass energy is a renewable source of energy, producing no greenhouse gas emissions or pollution. To recap, we solved the question by 1. Solar energy, 2. Wind energy, 3. Hydro energy, 4. Geothermal energy, 5. Biomass energy. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following statements about the principle of conservation of energy is/are true? I. Energy can neither be created nor destroyed. 2. Energy can be transformed from one source to another. 3. Total energy of the universe is not constant. Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following statements about the principle of conservation of energy is/are true? I. Energy can neither be created nor destroyed. 2. Energy can be transformed from one source to another. 3. Total energy of the universe is not constant. Now, try it yourself. Step 1. Define the system. When applying the principle of conservation of energy, it's essential to define the system. A system can be a single object, a group of objects, or a region in space. In this example, let's consider a ball rolling on a surface. Step 2. Identify the forms of energy. The ball has several forms of energy, including kinetic energy, the energy of motion, potential energy, the energy stored due to its position or configuration, thermal energy, the energy associated with the temperature of the ball. Step 3. Apply the law of conservation of energy. The law of conservation of energy states that the total energy of an isolated system remains constant over time. This means that the sum of all forms of energy in the system remains the same, but the forms of energy can change. Step 4. Use the energy conservation equation. The energy conservation equation can be expressed as delta E equals Q, W, where delta E is the change in energy, Q is the heat added to the system, and W is the work done on the system. Step 5. Identify the energy transfer mechanisms. Energy can be transferred from one form to another through various mechanisms, including conduction, the transfer of energy through direct contact, convection, the transfer of energy through the movement of fluids, radiation, the transfer of energy through electromagnetic waves. Step 6. Apply the principle to problems. Using the principle of conservation of energy, we can solve problems involving energy transfer and conversion. For example, if a ball is rolled up a hill, its kinetic energy is converted to potential energy. Step 7. Summarize the key concepts. In conclusion, the principle of conservation of energy is a fundamental concept in physics that states that the total energy of an isolated system remains constant over time. By defining the system, identifying the forms of energy, applying the law of conservation of energy, using the energy conservation equation, identifying the energy transfer mechanisms, applying the principle to problems, and summarizing the key concepts, we can solve problems involving energy transfer and conversion. To recap, we solved the question by 1. Define the system, 2. Identify the forms of energy, 3. Apply the law of conservation of energy, 4. Use the energy conservation equation, 5. Identify the energy transfer mechanisms, 6. Apply the principle to problems, 7. Summarize the key concept. Visit Passco.Africa for more solutions. Subscribe for daily WASSCE prep. Welcome to Passco Africa. Here is the question. Which of the following type of motion is predominant in the molecules of a gas sealed in a tube? Now, try it yourself. To recap, we solved the question by. Visit Passco Africa for more solutions. Subscribe for daily WASSCE prep.